Alright, this is Chapter 7, Section 3. This is the second video. So let's say we have an unknown distribution, right? That's fine. You can still do this as long as the sample size is large enough, right? So our rule of thumb, as long as we're 30 or more, we're okay. Right? Is that the true way of doing it? No, but for the sake of what we're doing, it's good enough, right? So our sample size is 100, so it doesn't matter if this is unknown. We're okay. We can still do it with a normal distribution to make estimations. So someone is assaulted every 2 minutes on average. The deviation is a half a minute. Okay, determine the median, first quartile, and third quartile, right? So basically the median is the second quartile, correct? So 25th, 50th, and 75th percentile. So we want to do this for the sample mean, right? And this question looks identical, except now it says the sum, right? So very similar. So this one is the sample means, this one is the sum for the quartiles. Okay, so we're going to do normal dot inverse 0.25 comma 2 comma 0.5 divided by the square root of 100, right? So we have 25th percentile, right, which is the first quartile, 2 minutes on average, 0.5 minute standard deviation, sample size of 100 samples that I take, essentially, right? So I'm going to get this number of minutes, essentially. Okay? I'm going to cheat a little bit. I'm going to copy this, paste it to here, paste it to here, because this one is the 50th percentile, and this one is the 75th percentile. So those are all the percentiles for the number of minutes it would take per assault, essentially, for a sample size 100, right? So 25th, 50th, and 75th percentile, and or the quartiles, depending on how you want to look at it, essentially. Okay. All right. So how does that differ from the next question? Well, that's the average of the group, right? 2 minutes. Average of the group 2.03 minutes. Well, this is asking for the sum of the groups. Add the group up, right? Add the group up. Okay. So what I'm going to do is I'm going to take this, copy it, and then paste it here. And I'm going to times it by 100 and times it by the square root of 100, right? Because essentially, again, this is the shorthand way of doing it. If I have the, actually, 0.5 divided by the square root of 100 times 100, that's the long way of doing it, correct? Right, because this is the first power, this is the half power, so this is the shortcut way, right? So 0.5 times the square root of 100 is a shortcut, because this simplifies to this, doesn't it? Because that's 1, that's a half, simplifies to a half, essentially, right? Okay, so that number of minutes is the 25th percentile, or first quartile, right? So if I add them all up, that's the number of minutes I will get. So I'm going to copy that, paste it, and change it to 50th percentile and 75th percentile. Okay, so if I take all 100 samples and I add them up, those are the number of minutes I'll get per quartile, essentially. Okay. All right. Let's say we want to figure out the number of the sample mean, right? So the sample mean, right, is between 1.75 minutes and 1.85 minutes. Well, the average is 2, so this is below average. I'm going to say this is probably a low probability, right? So what's the probability, right, that of that sample of 100 that I randomly pick is going to be within that range? That's essentially what I'm asking, correct? Okay, so normal dot distribution 1.85 comma 2 comma 0.5 divided by the square root of 100 comma true minus, I'm going to copy this to save a little bit of time here, and then change this to 1.75, right? So again, 2 is the average, and this is below average, so I'm going to guess this is not all that high of a probability. No, it's less than 1%, so it's like a little more than 1/10 of 1%, correct? Okay, so that's what I thought. So the sample probability is going to be less than 1% essentially. So 2 standard deviations, right? So this is going to be the mean of the samples, right, x bar, plus 2 times the standard error. Because it's 2 standard deviations above the sample mean, right? So essentially, that's what? 2 plus 2 times 0.5 divided by the square root of 100. Correct? There's 2 deviations. The mean is 2, the deviations is 2. 0.5 is standard deviation, sample size of 100. Okay, said that's going to work out nicely. Essentially, right? 2.10 minutes, that's 2 deviations above the mean, essentially. Okay, so if I have my normal distribution curve here, right? The mean is 2, so 2 deviations above is 2.10 if I'm using 100 as my sample size, right? So that's my x bar for 2 deviations above the average, essentially. Okay, determine the IQR for the sum. Keyword there is sum of the samples. So if I go back here, these are the mean of the groups. These are the sum of the groups. So the IQR here is Q3 minus Q1. That number of minutes is the IQR for the sum, essentially, right? Okay. All right, so let's compare Chapter 6 to Chapter 7, essentially. So a woman is between the ages of 18 and 24, have an average systolic blood pressure of 114.8 millimeters of mercury with a standard deviation of 13.1 millimeters of mercury. And we're going to assume that blood pressure is normally distributed, right? So that means we can do the Chapter 6 stuff. So if I select one woman from the population randomly, what's the probability their blood pressure is greater than 100? Okay. Versus selecting 40 people from the population, what's the mean systolic blood pressure is greater than 120? So that's asking about a group. So individual versus a group. Group average, one person. Okay, so normal dot distribution, 120, comma, 114.8, comma, 13.1, comma, true. Okay, so this is asking about one person, so I do not need to divide by the sample size. I could, because the square root of 1 is 1, so it doesn't matter, right? But I'm not asking 120 or less. I'm asking for more than 120 blood pressure. So very high blood pressure. That's the probability, correct? The second question, let's copy this, is asking about 40 women. So I have to do this and divided by the square root of 40. Okay, let's drag this out of the way. Okay, so this is 40 women, correct? So this is saying x bar. So this is Chapter 6. The individual woman we select randomly for the population is more than 120 blood pressure. We get about 34.5%. Versus the sample of 40, that mean of that sample, right? So therefore we could count for it by this. The standard deviation gets smaller. What is that probability? It's less. Because the average of the group is going to be a different probability than the average of the individual. Because the average of the group is going to be harder to come by, essentially. Okay? All right. So, average of the individual, right? Versus the average of the group. So here we're going to say the probability of x being greater than 120, right? The individual answer. We'll copy this. Here we'll paste, and we'll put a bar above it, because now it's the sample mean. There we go. Perfect. Okay. If 4 women between the ages of 18 and 24, right, so we select 4 this time, and we did not know the original distribution. The original distribution we're saying is normal, but what if we did not know this? Could we use the central limit theorem? No. So essentially we have a problem here, don't we? Correct? So what's essentially going on is the sample size is now below 30. That's a problem, correct? So the sample size is not big enough to ensure a normal distribution, essentially. It's essentially what our problem is now. Okay, because we have to have a sample size greater than 30, which 40 was fine. Okay, if it was normal, we could also do the individual. But if we don't know, we can't be doing individuals or 4 at that point, unless it's actually normal, which if we don't know that, we can't do it essentially. So that kind of ties in Chapter 6 versus Chapter 7, and the idea of having a big enough sample size to make it normal, which is what we proved in the beginning.